Welcome back. In the second part of this lecture, we'll be talking about some properties of our trig functions. And one of the properties of them is that our trig functions are periodic. Periodic functions are functions that repeat themselves. So the formal definition that I have here is that if a function is periodic, then there's some positive number p out there, so that for any value in the domain theta, f of theta and f of theta plus p should be equal to each other. Or in other words, that the y value for these 2 points are the same. Or in other words, the y values for this function repeats itself. For all of our trig functions, they're all periodic. And this is probably not a big surprise if you're just thinking about the fact that, for example, something like 0 degrees has the same terminal side as 360 degrees, which has the same terminal side as 720 degrees, which has the same terminal side as lots of other angles. And one thing that we know is that our trig functions, the values depend on where the terminal side is. And so if you have two angles with the same terminal side, they have to be equal to each other. So it's not really a big surprise here that several of our trig functions have a period of 2 pi, that they repeat their y values every 360 degrees. So sine, cosine, secant, and cosecant, those all have a period of 2 pi. So that means something like, for example, if you were interested in secant of 10 degrees, that would be the same thing as secant of 360 more than that, or 370 degrees. Two of our trig functions happen to have periods that are smaller than 360, tangent and cotangent. They both have periods of 180 degrees, or pi radians. So if you were interested in, for example, tangent of 10 degrees, that would be the same thing as tangent of 10 plus 180, or tangent of 190 degrees. So the way that we normally would use this idea of periodicity would be if you were interested in something like, for example, secant of 370 or some other large angle, you could subtract for secant multiples of that period, multiples of 2 pi or 360 degrees, until you're at a smaller and easier to deal with angle. And that similarly for tangent and cotangent, if you're interested in an angle like 190, you could subtract multiples of 180 or of pi radians until you get to a smaller and easier to deal with angle. Okay, so let's take a look at this here. We're looking at tangent of 13 pi over 4, which if you wanted to think about that in terms of degrees, that's 585 degrees. So if you were thinking about tangent of 585 degrees, that would be the same as going back 180 degrees from that, because tangent has a period of 180. And that would be the same as going back another 180 degrees, because again, tangent has a period of 180. And that would be the same as going back yet another 180 degrees, because again, tangent has a period of 180. I'm going to actually write this, though, in terms of radians. And what I'm going to do here is, instead of subtracting 180 degrees, I'm going to be subtracting pi radians. And if you're thinking about subtracting pi, that would be the same as subtracting 4 pi over 4. So 13 pi over 4 minus 4 pi over 4, that would give me 9 pi over 4. And if I wanted to go back another 180 degrees, subtracting another 4 pi over 4, that would give me 5 pi over 4. And going back another 180 degrees, subtracting another pi, which is another 4 pi over 4, that would bring me back to tangent of pi over 4. So these are all exactly the same angles that I had before, just written in radians rather than degrees. So if I'm looking for tangent of 13 pi over 4, which is 585 degrees, that's the same as finding tangent of pi over 4, which is 45 degrees. And I know how to do that. I just need to get my special triangle out. And I'm going to be getting out my 45, 45, 90 triangle, whose side lengths are 1, 1, and root of 2. And we know tangent of 45 should be opposite over adjacent, or 1 over 1, which is just 1. Let's do the same thing here for secant. So secant of 10 pi over 3, which, again, you could turn this into degrees if you wanted to, but I'm not going to. I'm going to deal with this the same way that we dealt with tangent. I'm going to remember that secant has a period of 2 pi, and so what I'm going to do is I'm going to take that large angle of 10 pi over 3, and I'm going to subtract a full circle. I'm going to subtract 2 pi. But 2 pi is the same thing as 6 pi over 3. So when I say that really I'm looking for secant of 10 pi over 3, that's the same thing as looking for secant of 10 pi over 3 minus 6 pi over 3, which is 4 pi over 3. And I know that I can't subtract another 6 pi over 3 from that because that would leave me with something negative. So I've taken away as many full circles as I'd like to do here. I'm also going to remember that for secant of 4 pi over 3, I'm actually going to answer that by finding cosine of 4 pi over 3, since secant of 4 pi over 3 would just be the reciprocal of that. Okay, so let's draw this. If you need to, on the side, figure out what 4 pi over 3 is as an angle in degrees, that's 240 degrees. You don't really have to, though, because if you're thinking about that this would be where 180 degrees or where pi would be, that's the same thing as 3 pi over 3, which means 4 pi over 3 should be beyond that, and that the reference angle should be the difference between pi over 3 and 4 pi over 3, which is 1 pi over 3. So in other words, my reference angle here is pi over 3, or 60 degrees. And what do we know? We know that in our 30, 60, 90 triangle, pi over 6, that's 30 degrees, pi over 3, that's 60 degrees. In our 30, 60, 90 triangle, if you were looking for cosine of pi over 3, that would be adjacent over hypotenuse. That would be a half. We also know that the quadrant that we're in is one in which cosine would be negative. Tangent is positive in this quadrant. So one thing that we know number 1, cosine of pi over 3 is a half. But we also know that cosine of 4 pi over 3, since that's in a quadrant where cosine is negative, should be negative a half. So we have then for our answer here, it's 1 over negative a half, which is the same thing as negative 2. So secant of 10 pi over 3, that is negative 2. We also have some symmetry properties for our trig functions that can be helpful here. All of our trig functions have some type of symmetry. Sine and tangent and cosecant and cotangent, those are all odd functions. Secant and cosecant, those are both even functions. So this helps us out when we're thinking about finding trig functions of negative angles. For example, if you were looking for cosine of negative 73 degrees, you know that cosine is an even function. So for an even function, you know f of negative is equal to f of positive. Or in other words, cosine of negative 73 should be equal to cosine of positive 73 degrees. And similarly, for an odd function, you can also use that property if you had an odd angle, a negative angle to look at. If you were looking at sine of negative 40 degrees, that should be the negative of sine of 40 degrees. And that's because sine is an odd function. So that's one way in which we can deal with negative angles. We could use the symmetry properties of our trig functions. So really, the only thing that we need to remember here is that cosine and its reciprocal, those are the only even functions. The other four, those are all odd. So, for example, here, we're looking for secant of negative 30 degrees. And I know that secant is an even function, so secant of negative 30 should be the same thing as secant of positive 30. And secant is the reciprocal of cosine, so that should be the same as 1 over cosine of 30 degrees. And then I just need to use my special triangle for the 30, 60, 90 triangle. And cosine of 30 should be adjacent over hypotenuse, which is root 3 over 2. So we get 2 over root 3, which in simplest terms would be 2 root 3 over 3. And let's do another one here. We're looking for tangent of negative 4 pi over 3. I'm going to do two things here. First, I'm going to use the fact that we have tangent as an odd function. So tangent of negative 4 pi over 3, that's the same thing as negative of tangent of 4 pi over 3. I'm also going to use the fact that tangent has a period of pi. So if you're looking for tangent of 4 pi over 3, that's the same as tangent of 4 pi over 3 minus pi, minus 180 degrees. And pi is the same thing as 3 pi over 3. So if you're looking for tangent of 4 pi over 3, that's the same thing as looking for tangent of pi over 3. So what I have here on the, instead of negative of tangent of 4 pi over 3, that's really negative of tangent of pi over 3. So I've used actually two properties of my trig functions here. First, I took the negative outside using the fact that tangent is odd. Then I turned it from tangent of 4 pi over 3 to tangent of pi over 3 using periodicity, using the fact that tangent has a period of 180 degrees or pi radians. And now we're just going to get out our 30, 60, 90 triangle. And for 60 degrees, or pi over 3 radians, tangent is opposite over adjacent, which is root 3 over 1. So we have negative of root 3 over 1, which is just negative root 3. I do want to say, before moving on to my last example here, you could tackle this in another way if you felt like it. So if you wanted to, you could ignore all the properties that we have and start out by drawing negative 4 pi over 3 as an angle, figuring out what the reference angle is, the reference angle being positive pi over 3, then using the special triangle and the fact that in that quadrant tangent is negative, and you could come up with exactly all of the answers that I came up with here using both the fact that tangent is odd and also has a period of 180. That's, like I say, one of the strengths of our trig functions. If you know these properties, you can use them, but you have ways to work around them if you don't think about using those properties. So you could have done this exact problem even in the previous section, but now that you know that tangent is odd and that tangent has a period of 180, that does help simplify the work that we've got to do. Okay, one last one to do here. I've got cosine of negative 5 pi over 6, and I know that cosine is an even function, so that's the same thing as cosine of positive 5 pi over 6. And just to draw that, I know 180 degrees, or pi, is the same thing as 6 pi over 6. So 5 pi over 6 is just a little bit less than that, and must be pi over 6, which is 30 degrees away from the x-axis. So I know that my reference angle here is pi over 6, or 30 degrees. And if I'm getting out my 30, 60, 90 triangle, I can say that cosine of pi over 6, or in other words, cosine of 30 degrees, is adjacent over the hypotenuse, which is root 3 over 2. I also know that in the quadrant where we're in, which is quadrant 2, cosine is negative. It's sine and cosecant that happen to be positive. So cosine of 5 pi over 6 should be negative, and it should be negative root 3 over 2.